Polarization. What is polarization? Even if you talk about in the daily life about the polarization, like you have heard people get polarized. So now here we are going to discuss what is polarization and what are the different types of the polarization here. And again, by the limiting case of one polarization, how we are going to obtain the another polarization. Okay, let's start with the polarization in the electromagnetic wave. So still, if you didn't subscribe our channel, please subscribe, like and share with your friends. And we have a course for this electromagnetic theory so that you can see all previous lectures. So what is polarization? So polarization is the property of the transverse wave which specific the geometrical orientation of the oscillation. How that oscillation have orientation in the 3D space. So that is being discussed with the help of polarization. So how this orientation takes place when wave is going to propagate electric field or magnetic field when it is going to move. So already we have seen that if wave is going to propagate along the z direction, then we have considered that how orientation of the electric field is either in the x direction and magnetic field in the y direction. So like this, we are going to consider here also. So the polarization of uniform plane wave we are going to consider here. And uniform plane wave means the electric field and magnetic field will have same magnitude at that plane at particular instant of time. So here time varying behavior of the electric field intensity factor at some fixed point we are going to see. Okay. So now here if you see that we have three different types of the polarization: linear polarization, elliptical polarization, and circular polarization. So in case of linear polarization, and here the direction, this if you see that here we have dot with circle. It shows that wave is propagating outwards along the z direction. So here electric field component in case of linear polarization that have orientation along the y-axis, and it has amplitude lies between plus E2 to minus E2. So in this between only wave is going to oscillate. That electric field is going to oscillate in between. Whereas here in case of elliptical polarization, so elliptical or ellipse, you know that it has major axis, minor axis, or even if you talk about the satellites, so that rotate on the elliptical path. So for that you have Kepler's law and all those things you'll study in the higher class. So now here we are considering that this electric field component which is along the y-axis E2, which will have another component here that will be the E1. Okay, so two different components at a time, E1, and this is again E2 will be there. So one will represent the major axis, another will represent the minor axis. So like if you take the ellipse, or if you can consider the shape of the egg also. So this is the major axis. Okay. And we have another along this. This is the minor axis. And third one is the circular polarization. So in case of circular polarization, the component E2 and E1 both are same magnitude. Okay. Will have same value. So that again we'll discuss about that. So let's see about the linear polarization. Okay. The electrical vector is remain only in one direction all times. Like here we have considered it is in the direction of y. Positive y, negative y. An electric field of a linearly polarized wave progressing in the positive z direction, then wave is equation is given as Ey equal to E2 sine omega t minus beta z. So E2 is the magnitude. So we have seen in case of linear polarization, that electric field magnitude is going to vary between positive and negative value of E2. But direction is confined to the y direction only. Okay. Direction is confined to the y direction. That is very important. Next, we have elliptical polarization. So in case of elliptical polarization, the wave still we are considering that wave is propagating in the z direction. And in this figure, we are considering that z is the outward from the paper. Then it may contain the x component also. Okay, so already we have seen in case of linear polarization, it has y component only. But in case of elliptical, it might have x component also. So thus such type of the polarization in which it has y component as well as x component also for the particular instant of time, then it is called as the elliptical polarization. So for the particular fixed value of z, means in particular plane, E is going to rotate as the function of time, and the tip of the electric vector E describes an ellipse. So how that wave is going to move? So that is going to form the shape of ellipse. So here it is the maximum, here it will have minimum value. So such type of the ellipse is going to occur due to elliptical polarization. So in case of elliptical polarization, it is important what is the axial ratio. On the basis of axial ratio, we can get the condition for the linear polarization as well as condition for the circular polarization. So name itself is what? Axial ratio. Okay. The ratio of the two axes. So ratio of the major axis and minor axis of the polarization is called as the axial ratio, and it is represented by ER. So finally, we have seen that for the major axis, that value is E2, and for the minor axis, this value is E1. So this ratio of E2 by E1 is called as the axial ratio. So here you can see that at point P, we have major axis, and here we have minor axis. So along the y direction, its component is E2. Along the x direction, its component is what here? E1. Okay. So this is the situation of the elliptical polarization. So now this linear polarization or plane polarization and circular polarization, as we are discussing that, it is the special case of the elliptical polarization. Now if this E1 and E2 both are going to equal, okay, so that means the value of the major axis and minor axis, that value becomes same. So then it becomes the circular polarization. So in case of circular polarization, axial ratio is equal to 1. Whereas in case of linear polarization, the special case of elliptical polarization, if E1 value becomes 0. So if E1 value will become 0, then what will be the axial ratio? It will be E2 by 0. So E2 by 0 is what? It is the infinity. So axial ratio in case of linear polarization will be infinity. In case of circular polarization, it is the 1. So when two linearly polarized component waves are in the same time phase, okay, or you can consider that it has equal magnitude but time phase having quadrature. So quadrature total is, you know that it is the 360 degree. So time phase quadrature means it has phase shift of 90 degree, and also equal in magnitude, then resulted wave is the circular polarization. So wave amplitude is going to become equal, E1, E2 is going to become equal, but have quadrature phase shift of the 90 degree. Okay, so that is called as the, again, circularly polarized wave. So like this, we have discussion about polarization. So polarization is the orientation of the oscillation when wave is going to propagate. How this electric field and magnetic field have orientation. That is the call as the polarization. So we have, later we have another different type of the polarization also, but here this is the basic polarization what we are talking. whether we have vertically polarized wave or we have horizontal polarized wave. Okay, that discussion will come later. So here we have seen what is polarization and three different types of the polarization: linear polarization, circular polarization, and elliptical polarization. And what is the axial ratio? And from the elliptical polarization, how we can get the different condition to obtain the linear polarization as well as circular polarization. Okay, like, subscribe our channel so that our community will improve. Thank you very much.